Intermediate lighting and cycles setup in Blender. Introduction.
In this video, we'll explore different types of lights, their settings, and how to create effective lighting setups for your 3D scenes. By the end, you'll be able to enhance your models with intermediate lighting techniques.
Light types. The sun light.
This is used to simulate sunlight, providing parallel rays that are great for outdoor scenes.
The point light. It emits light in all directions from a single point, similar to a light bulb.
The spotlight emits light in a cone shape, perfect for focused lighting, like a spotlight on a stage. Area lights provide soft, even lighting over a specified area, ideal for soft shadows and diffused light. All light types work in either EV or Cycles render engine.
HDRI lighting. We can use an HDRI to light our image in both EV and Cycles.
Note, if you use an HDRI for lighting in EV, it will not cast shadows.
You will need to add secondary lighting to cast shadows in EV. An HDRI will cast shadows when rendering with Cycles. Emissive textures. An emissive texture is a special type of material that emits light into the scene. Emissive textures work in both EV and Cycles but require more setup in EV to achieve similar results as Cycles. I have created a scene containing the different light types available. And we will be using the Cycles render engine for this demonstration.
The primary differences between EV and Cycles are in how they handle bounce lighting. To save on processing time and power, the EV render engine does not calculate the bounce lighting.
While this is faster, it results in less accurate lighting.
It is called real-time lighting due to the fact that it is calculated in real time. Cycles, on the other hand, does calculate the light bounces from one object to another.
This results in slower, but more accurate lighting calculations.
This is often referred to as baked lighting due to the fact that it is pre-computed and not easily changed.
Setting up Cycles.
After you have set up your folder structure and saved your file as discussed in previous videos, it is time to change the render engine in Blender. Navigate to the Render Properties panel on the left-hand side of the screen.
Using the render engine drop-down, choose Cycles from the list. Now navigate to the Edit drop-down menu from the top bar and select Preferences. In Preferences, choose the System tab. At the top under Cycles Render Devices, you should see your GPU and CPU listed. If not, click CUDA, Optics, HIP, or One API if your machine has supported hardware, it will appear here. The two most popular are CUDA and Optics. Both CUDA and Optics have their strengths, and the best choice depends on your specific needs in hardware. CUDA works on all NVIDIA GPUs.
Generally faster for simpler scenes or when using simple materials.
More mature and widely supported across different software. Optics optimized for NVIDIA RTX GPUs, utilizing their ray tracing cores.
Typically, 60 to 80% faster than CUDA for complex scenes with lots of reflections and refractions.
Provides significant speed improvements in rendering Cycles.
If you have an RTX card, Optics is usually the better choice due to its speed advantages in complex scenes.
For non-RTX cards, CUDA is the way to go.
Once you have made your selection, click the three lines at the bottom of the Preferences panel and save your preferences. Close the Preferences window, navigate back to the Render Properties, and in the Device drop-down menu choose GPU.
Let's explore a few more options in the Cycles render engine.
In the Sampling Viewport rollout menu, change the number of samples to 32. The default is set to 1024, meaning the viewport will sample the scene 1024 times every time you make a change.
The more samples, the longer it will render.
This can cause your machine to slow down while working.
In the viewport, 32 samples are plenty. In the Render Rollout menu, change the number of samples to 128. The more samples, the better the image will look, but also the longer the image will take to render. 128 samples is a nice balance between quality and render time. Light settings.
All the lights have the following properties in common.
Color determines the hue of the light emitted.
You can choose any color to set the mood or match the lighting conditions of your scene.
For example, a warm yellow light can simulate sunlight, while a cool blue light can mimic moonlight. Power controls the intensity or brightness of the light.
Higher values make the light brighter, illuminating more of the scene.
This is measured in watts for point, spot, and area lights, and in nits for emission shaders.
Max bounces sets the maximum number of times light can bounce off surfaces in the scene. Higher values result in more realistic lighting, as light can interact with more surfaces, but this also increases render times.
Lower values can speed up rendering but may result in less accurate lighting.
Cast shadow. This option determines whether a light source will cast shadows from objects in the scene. When enabled, objects will block the light and create shadows, adding realism to the scene.
Disabling this can be useful for artistic effects or to reduce render times.
Multiple importance. This setting helps to reduce noise in renders by combining direct and indirect lighting calculations. It is particularly useful for HDRI environments and emissive materials. Enabling multiple importance sampling ensures that light sources are sampled more efficiently, leading to cleaner and faster renders. Shadow caustics. Caustics are patterns of light that are focused through reflection or refraction, like the light patterns at the bottom of a swimming pool. In Blender, enabling shadow caustics allows for the simulation of these effects, adding realism to scenes with glass, water, or other refractive materials. This can increase render times but significantly enhances the visual quality. The following properties are specific to the light type mentioned.
Sunlight.
The angle property for the sunlight in Blender controls the apparent size of the sun, which affects the softness of the shadows it casts.
How it works. Smaller angle. When the angle is set to a smaller value, the sun appears as a smaller, more distant light source.
This results in sharper, more defined shadows, similar to a clear sunny day. Larger angle. Increasing the angle makes the sun appear larger, simulating a more diffused light source. This creates softer, more diffuse shadows, similar to an overcast day or the light during sunrise or sunset. Adjusting the angle can help you achieve the desired mood and realism in your scene by controlling the sharpness of the shadows cast by the sunlight.
Point light.
Radius. This controls the size of the point light source. Increasing the radius makes the light source larger, which can soften the shadows it casts. A larger radius simulates a larger light source, like a big light bulb, while a smaller radius simulates a smaller, more focused light source.
Spotlight.
Size. This refers to the angle of the cone of light emitted by the spotlight. A larger size means a wider cone, illuminating a larger area but with softer edges. A smaller size means a narrower cone, focusing the light more tightly and creating sharper shadows. Blend. This controls the softness of the edges of the spotlight beam. A higher blend value results in a softer transition between the illuminated area and the surrounding darkness, creating a more gradual falloff. A lower blend value creates a sharper edge, making the spotlight beam more defined. Radius. This adjusts the size of the spotlight beam. Increasing the radius makes the beam wider, covering a larger area, while decreasing it narrows the beam, focusing the light more tightly. Show cone. Toggle the cone on or off in the viewport. Does not affect the render.
Area light.
Size. This controls the dimensions of the area light. Area lights can be rectangular or square, and the size determines the width and height of the light source. Larger area lights produce softer shadows and more diffuse lighting, while smaller area lights create sharper shadows and more focused lighting. Portal. This option is used to guide light from an environment texture, like an HDRI, into an interior scene. When you enable the portal option for an area light, it doesn't emit light itself but instead helps to direct the environment light into the scene more efficiently. This can significantly reduce noise and improve the quality of indoor renders with HDRI lighting. It's particularly useful for scenes with windows or other openings where you want to bring in natural light.
Spread. This controls the distribution of light emitted by the area light.
A lower spread value results in a more focused, directional light beam, similar to a spotlight. A higher spread value makes the light more diffuse, spreading it out over a larger area. Adjusting the spread can help you achieve the desired lighting effect, whether you need a concentrated beam or a soft, white illumination.
Creating an emissive texture.
Creating an emissive texture in Blender for cycles is a great way to add glowing effects to your models.
Here's a step-by-step guide to help you set it up. Click on the object you want to apply the emissive texture to. Switch to the Shader Editor workspace. Create a new material. Press Shift+A to open the Add menu, then select Shader Emission. Connect the emission shader to the surface input of the material output node. Set up the emissive texture. To use a color, click the color swatch to set the color, then proceed to the next step. To use an image, do the following. Add image texture, press Shift+A and add an image texture node. Open texture file, click Open and select the image file you want to use as the emissive texture. Connect image texture, connect the color output of the image texture node to the color input of the emission shader. Adjust the strength value of the emission shader to control the intensity of the glow. Higher values will make the texture emit more light. Setting up HDRI. Setting up an HDRI, high dynamic range image, in Blender cycles is a great way to achieve realistic lighting and reflections in your scene. Here's a step-by-step guide to help you set it up. Find an HDRI, download an HDRI image from a reputable source. Websites like HDRI Haven offer a wide range of free HDRI images. Shader Editor, switch to the Shader Editor workspace and select World from the drop-down menu at the top. Add Environment Texture, press Shift+A to open the Add menu, then select Texture Environment Texture. Open HDRI file, click Open and select the HDRI image file you downloaded. Connect nodes, connect the color output of the environment texture node to the color input of the background node. Step 4, adjust HDRI settings. Strength, adjust the strength value of the background node to control the intensity of the HDRI lighting. In this lecture we discussed the different light types and their settings in detail. We explored different ways to light our scene including lights, emissive materials, and HDRI. We looked at the differences between EV and cycles. You now have the tools to explore creative ways to light your Blender scene. Happy blending! See you next time. Written and recorded February 2025.